Yeah, so we can use that rectangular coordinate system to graph some equations, and specifically in two variables. The first type of equation we're going to talk about is a linear equation in two variables. Let me just write one up here, example for you, and talk about it. All right, so here's an example of a linear equation in two variables. It's obviously in two variables. We'll talk about the linear, why it's linear in just a second. But yeah, so this is one of the reasons why we need that rectangular coordinate system, because when you have two variables, a solution to the equation, you're going to have an x and a y. And so, for example, 4, 2 here is a solution, isn't it, to that equation? How do I know that? Well, if you plug in, that's x, that's y, right? X is 4, then the y is 2, and so you got 4 plus 4, yeah, that does equal 8, you see. So, just to verify it there. Yeah, so solutions to these are those ordered pairs, and so we'll plot these in just a second. So is 2, 3 a solution? So that, I don't know if they ask any of these, but good. Is 2, 3 a solution to that equation?
Yes.
X is 2, y is 3. 2 plus 2 times 3, that's 2 plus 6, that is, yes, so it is. What about 0, 4? Is that a solution? 0 for x, 4 for y, 0 plus 8, yes. Not writing it out, but yes, it is. Negative 2, 5. Negative 2 for x, 5 for y, does that work? 5, negative 2 plus 10, yep, got one there. So there's a bunch of, it's not just one answer, right? When you get two variables, you got many, many answers. Now, it's not necessarily all the time. What about 5, 1? Is 5, 1 a solution?
No.
Yeah, 5 plus 2 times 1, that's 7, isn't it? Not 8. So it's not, you just can't just throw up two numbers up here. They are related somehow or another. And one other, or this is probably more the way they'll ask one of the type of questions they'll ask. All right, so 5, 1 doesn't work. What if I did have the y is 1? How could I get the x? Well, fairly easily, right? Because this tells me the y is 1, right? And so if I put that in, so x plus 2 times 1 equals 8, that's just a simple solution, right? We'd have minus 2, so x is 6. So it'd be 6, 1 instead of 5, 1. Okay, so this one didn't work, but all the rest of these do. So you can see, yeah, there's a multitude of solutions. Okay, now another way they'll sometimes arrange these solutions is with a table of ordered pairs, or call it a table, XY table, T table. Sometimes they refer to it. I don't think this book does, but. Yeah, if we put the x, y's in a table, so we'd have x is 4, y is 2, 2 goes with 3, 0, 4, negative 2, 5, and then 6, 1. It's just another way to arrange solutions to a particular equation. And we utilize that more in just a second. Now, all right, so last but not least here, all right, so how are these related? Well, that's where we pull out the old Cartesian coordinate system, or rectangular coordinate system, the XY plane, sometimes they call it. Yeah, because we can plot all these points and notice a pattern here, hopefully, if we did them right. All right, so let's plot all these points to graph So here we're graphing x plus 2y equals 8 by plotting the points or the solutions that we found. That's what we're doing here. Try to get these pretty square. If you like graph paper, it's fine, you don't have to, but sometimes it's helpful to be nice and square, but anyway, we'll try it, see how it goes. All right, so we got 4, 2, x is 4, y is 2, so that'd be here. We got 2, 3, x is 2, and y is 3, so we got here. We got 0, 4, so that's right on the y-axis, x is 0, y is 4. Negative 2 and 5, so that's back, x is negative 2, y is 5. And then we got 6 and 1. There. All right. So, yeah, we can maybe now see why this is referred to as a linear equation, because these all points-wise are lining up in a nice little straight line, aren't they? So, any solution here, so if we connect the dots, then extend it past those, because, yeah, that pattern is going to continue. And so the graph of this is a line. And hence the name a linear equation, because the graph of such things are lines. Okay? Yeah, so it turns out anytime we have a similar situation as far as equation goes, those are going to be, graph-wise, those are going to be lines. Now what's the trademark here of a linear equation? Well, yeah, anytime we have ax plus by or minus by equals a number, where the a, b, and c are just numbers there, that's referred to as a linear equation in or one form of it, standard form, sometimes they call it. That's standard form. So significance is you got x to a power of 1 and y to a power of 1. You know, the numbers can be positives or negatives. So we've seen one example here of that. X plus 2y equals 8. Well, anytime you have a similar situation, yeah, you've got a linear equation. You've got a line to graph it. All right. So let's do another one here. All right, so let's complete the table for 3x minus 2y equals 12. Here's the table I want us to complete. All right, so yeah, they what they've done is they've just given us, or I've given you half the answers in each case. So you just have to go in and solve by plugging in, right? This one I've got x is 0, and so here, yeah, just plug in the x to be 0. Some of them are easier. Some of these will be easier than others. Of course, x is 0, so that makes this 0. So it's just minus 2y equals 12. So just solve that, just divide by negative 2, right? We got y equals negative 6 to go with that. Second line, we got y is 0, so doing basically the same thing, except y is 0. Well, that's going to make that 0, so it's 3x equals 12, so easily divide by 3, you got x is 4. My x value would be 4 with that. So just, yeah, you're just completing along the way. The rest of them, all right, so this one you have negative 2 for x. That's a little more, but not too much. You got 3 times negative 2 minus 2y equals 12. negative 6 minus 2y equals 12. Yeah, so it didn't zero out, but just adds basically one more step because, yeah, just add the 6, right? That'll make it negative 2y because that'll go away. Equals 18, so we divide by negative 2. We got y is 9. That would complete that point. The others, real quick here, so we got this one, we got y is 3, so we plug in the y to be 3, so that would be 3x minus 6 equals 12. So again, we'd add the 6 and then divide by 3. Sound okay? 6, did I do this right? Trust me on those? All right, last one. Sometimes this will happen, but it's okay. All right, so the last one we got x is 1. Those all came out real nicely, but when we plug in x to be 1 here for the last one, right? 3 minus 2y equals 12. Well, we get subtract 3. That'll get rid of the 3 and get us negative 2y equals 9. And yeah, so they don't always work out to be a whole nice integer whole number. Negative 9 halves, and again, probably decimal form would be a little better, negative 4.5 for graphing purposes. So how are we going to list it there? All right. So now let's graph this equation. And we'll graph all 5 here, but we'll make a note here, one thing. All right, so 0, negative 6. Line's marked off here. Straighter. So 0, negative 6, that's our y-axis point. 4 is 0, be on the x-axis. X is 4, y is 0. Negative 2 and negative 9. So back to negative 2, down here to negative 9. 6 and 3. 6 for x, 3 for y. And 1 and negative 4.5. Somewhere along here, right? Yeah. So nothing else that checks to make sure these are all right because, yeah, it's one of these linear equations, so they should all be lining up. And they do. So the graph of the equation is that line through those. But one thing we could point out here is really, once we had 2 of them, we had it pretty well figured out, didn't we? Like the first 2 here, if I just done these 2, yeah, that line's established. So really all you need is 2 points, and we'll take that into consideration here on a couple others for just a second. All right, but now let's note a couple of, call them special points, but 2 points, usually 2, that we need to focus here on are the x-intercept and the y-intercept. And the name, of course, kind of gives it away here. An x-intercept's where it intercepts the x-axis. So that x-intercept's where it crosses the x-axis. And the y-intercept's the reverse there, crosses where it crosses the y-axis. And so in this particular case, here's where it crosses the x-axis, so that's our x-intercept. And we might note that's 4, 0. And then it crosses the y-axis right here, so that's our y-intercept, 0, negative 6. And so if we think a little bit about it, yeah, we already have it graphed here, but if we think about a little bit about it, to be on the x-axis, you'll always have the y as 0. So for the x-intercept, the y value is always 0. If you have an x-intercept, the y value has to be 0 because it's got to cross that x-axis. So being on the x-axis, it has to have the y value 0. And then vice versa, right? For the y-intercept, the reverse is true, right? The x value has to be 0. So we can use that to our advantage if we don't have those intercepts and they ask for them. That's a pretty easy way to find them. So let's take a look here at this one. So it'll tell us find the intercepts in the graph. These. Number 1, we got 2x minus 5y equals negative 4. So I just want to find those intercepts. Well, since I don't have the table all spelled out for us, yeah, the x-intercept, we know that the y value has to be 0. So that pretty well locks it in. We've got the y value of 0, so the x-intercept I'd have 2x minus 5 times 0 equals negative. Yeah, to find the x-intercept, you just let y be 0. And then solve. Of course, that's the nice ones because that'll zero that out. 2x equals negative 4. Divide by 2. And so that's x equals negative 2. Is my x-intercept, or the x value. Ordered pair specifically is negative 2, 0. And I would probably recommend you do that because sometimes these two get combined and that's incorrect. Yeah, the point is actually negative 2 for x, but the y value is 0. Right. Then my y-intercept, well, the x value is 0 on it, right? Talk about that. So easy enough. If you're wanting to find the y-intercept, you just set x to be 0. So that makes, of course, the x term 0. So we have negative 5y equals negative 4. So my y-intercept is, the y value anyway, is positive 4/5, or 0.8. On the decimal there, it's not quite 1. So that makes the the y-intercept point-wise, it'd be x is 0, y is 0.8 or 4/5. So those are my intercepts there. And then it says, second part, graph that. Well, we've got 2 points, so I don't need to do a table or anything. 2 points determine a line. And so the graph of this equation, now if we put these up here, negative 2, 0, it's on the x-axis. Where's that one? Back to negative 2. Y-intercept, 0.8, so it's not quite 1, so it's on the y-axis, but it's 1 there. That's enough to graph it because we know this is a line, it's a linear equation, standard form there. 2 points determines a line, so you got it. So that's a pretty quick way usually to graph a linear equation with 2 variables. Is that all right? Pressure to turn? All right, now, one other example here of this. Same instructions here. For number 2, find the intercepts in the graph. This one, however, has a little catch. X plus 2y equals 0. So finding the intercepts, a couple ways to do this, but you may know other ways, and we'll talk about other ways. But for now, all right, find the intercepts in the graph. So the x-intercept, we set y to be 0. Right? That's how the x-intercept, so you set the other one equal to 0. Well, that zeroes that out. That makes x is 0. So y is 0 and x is 0. Well, here's the catch, because doesn't that also mean, all right, so the y-intercept is set the x equal to 0. And look at that. Of course, it's also y is 0. They're the same in this case. 0, 0 is what we get out of both of these computations. So that's the catch here. Both of those are 0. And so when we go to graph this thing, we've got a problem because we only have 1 point. We need 2, don't we? So when you get zeros on both of them, yeah, that just gives you 1 point. So that's the little catch here, doing it this way. With what we talked about so far, one way we can handle that, so another point here, really as of your picking, just pick something other than a 0, say complete x is 1 or y is 1. Really anything you want to there. There may be other points better, but we need another point. So if x is 1, we have 1 plus 2y equals 0. So we just have to solve a little bit there. Negative a half. So that gives us another point, 1 and negative a half. Should be x is 1, y is negative a half. Should be right there, right there, 1. Somewhere along there. Just need another point of your choosing. Anything besides a y or x is 0. Because that gives you 2 points. We know it's a line. So. All right? All right.